Welcome to 3311. First of all, I'm not Jack. I'm not Professor Jiang. He is traveling currently for a conference in France, and he's coming back next week. Okay, I'm just covering the lecture for him. What I will do today, you can leave the self-introduction for him to do, maybe next week when he comes back. Okay, but I'm actually the instructor for the other section A. But usually, if you got any questions about the labs or about the projects, you should really just post the question on the course Moodle, which I'll go over in just a moment. Okay, I don't need to do any self-introduction. You don't have to know me well, since I don't look after you, but I'm Jackie anyway. Okay, so what I would like to do, first of all, before I go to the lecture, I would like to just go over with you how the course is going to be structured. I think you should really know. Okay. I suppose all of you receive an email from me, right? The Moodle announcement. Okay. So for those of you who may be on the waiting list, so you didn't receive the email from me from Moodle, please get in touch with me just after class so I can add you manually to the Moodle. Okay. Let me just go over the syllabus very quickly. But if you got any questions about the course, just interrupt me. Okay. Okay. First of all, Okay, I'll just go over. So for prerequisite and also course description, so these are, for course description, you can read it a little bit later. So it wouldn't make much sense for now. We'll do something fun about Java today. Okay. Okay, course learning outcomes. Usually I tell my students to maybe review the course learning outcomes as we go for the course. Again, it wouldn't make sense at this point. So there's no point for me to just read them through. Okay. Now, textbook. You know what? Let me just give a very quick try. As far as I know, Moodle has been incredibly slow throughout the day. Am I right?
Oh, yeah. Not only Moodle, just also your course.
Wow, that's incredible, right? Let me just give it. Okay, never mind. They didn't remove the this label here, so let's not bother trying. So when you log into Moodle, basically there is a merged Moodle site for sections A and E. You should always go there to check for lab instructions. Just go there. So whenever I say the labs are released, for example, lab 0 is released, always go there to check the PDF. So lab 0 is already released. One of the question is lab 0 going to be graded? No. However, you want to complete lab 0, and also there's a video tutorial I sent to you about doing Eiffel Studio and design by contract and test-driven development. You want to complete those tasks, even though they are not graded, by the end of the week. They will prepare you well for the lab, which will be graded starting from next Wednesday. Okay, hopefully that's clear to you. Please, maybe when the Moodle doesn't get so annoying, so you can log in and then try to find out more details. But I'll go over things with you. By the way, for today's lecture, what you can do is just go to my webpage, eecs.yorku.ca, Jackie, that's me. Just go to lectures over here. You will see under guest lectures. Okay, just go there and find today's session. But later on, if you somehow want to review certain concept, so the topics between the two sections are completely in sync. So if you want to reiterate certain concept, you can feel free to go to the same page, but they will be just under 3311 over here. Okay. But I think Professor Jiang will definitely look after you well, so I wouldn't worry. Okay, that's about the website you should go into. Okay, and then let me just go to the syllabus. So now there will be one single required textbook, which is called Object-Oriented Software Construction. So that one tells you how to do designs and how to do object classes, inheritance, etc. It's a very good textbook. However, we got permission from the book author. I already put a PDF on the course Moodle. However, for you as a student, you can use it for your own purpose for EECS3311. You are not supposed to distribute it for any purpose. Okay? For example, you're not supposed to print it out and sell it. You're not supposed to. Okay? Okay, hopefully that's clear. Okay, that will be the required textbook. And it's a very good book. Oh, there's a caveat I would like to mention. The textbook there mentioned many syntax about Eiffel, but the syntax might be a little bit obsolete, some of the syntax, but not many, just some of them. So don't be too distracted by the syntax. So try to learn the concept from there. Okay. So for the slides, usually I think Professor Jiang, he will also put a required reading chapters there for you to go through. But I think for today's lecture, you want to start with chapter 11. Okay, so that's a chapter about decide by contracts. Okay. Okay, references. So there's another book. That one's more primitive about IFO. Okay, so IFO I will emphasize a little bit more, but this is just a book for more about the computational thinking with the IFO language. Again, you don't need to purchase this. Just go to the library online, and then you can also get free access to that. If you got trouble with accessing this book, just go to the library, Stacy Science Library, and the librarian will help you with that. It's free, okay, for your students. Okay, one more textbook over here. This one here is not really available from our site, but this one is also worth considering. It's called Design Patterns, Elements of Reusable Object-Oriented Software. So throughout the course, we're going to mention a number of design patterns. So those are the reusable solutions for object-oriented software. So I think that one would be quite a nice one to have. The language there is C++, not exactly Java or IFO, but again, it's for the ideas. This one, you might be able to find some online version, okay? But I'm not encouraging you to do that. Maybe you should really just get maybe from Amazon, there might be a cheap version of that, like a used book. Okay, one more thing. Number 3, so this is so-called a BOM notation. So business object notation. So this is the standard for this course for you to prepare reports for lab and projects. So the BOM notation is rather easy. Basically, for the BOM diagram, which we'll cover more about how you should do the diagram as we go along the course. But that diagram there is basically you want to show the architecture of your classes and also put contracts in the diagram. Okay, so that's something you will get more examples as we go through. But there's some authoritative guide over there. You are not supposed to read it from the beginning to the end. Only refer to it when you need reference. Okay. Okay, that's about the resources over here. And also, when you see the instruction for lab number 0, there is some wiki site which I included. So this wiki site maintained for the IFO resources like a source code or some maybe some tips. Just go to the wiki site, explore yourself. You can feel free to use any of the source code we posted on that wiki site for your labs. Okay. Any questions so far? We okay, right? Yeah. For lectures, doesn't apply to you guys, I'm afraid. But for the labs, there's something I want to mention. It happens that the other section and your section, so all the labs happen on a Wednesday. So later on, as I go through, we're going to have one midterm test. We're going to have one lab test, so 2 tests basically in the middle of the semester. And they will be held on Wednesday, okay, the same day. So you're encouraged maybe to form study mates from other section and study together. That's absolutely fine, since the topics will be synchronized between the 2 sections. Okay, attendance. Well, if you can come to class, that'd be great. You should really come and have some peer pressure, to learn. That's always my recommendation. Okay. Okay, for the lab test, me and Professor Jiang will decide a little bit later in terms of the formats. But I can tell you that lab test is mainly going to be a programming test. So we understand that IFO is a new language for you to learn for this course since you are so familiar with Java. So we give you time to really pick up the language. For you as an engineer, right? So you're supposed to pick up any new language you are assigned to. Hopefully that's also a good chance to test your ability to learn new stuff. The lab test is going to occur quite late in the semester, so you do have enough time. Just make sure you always do the labs with a steady pace. You'll pick up the syntax, hopefully within a month. Okay. Grading scheme. There will be 5 lab submissions. Each one of them will be 4%. Usually there will be 2 components for each lab. There will be a programming part for which you have to do in IFO Studio. That's why getting the tutorial videos completed in week 1 is so important. Okay, I cannot emphasize that more. And usually for each lab, you should also prepare some simple report, BOM diagram. Okay, so that's BOM diagram notation you should pick up as well. Okay, and then at the end of around maybe shortly after the midterm, which is after the reading week, we will have some project release for you, the bigger one. The project, we believe that's really the goal for this course because we want you to work with close to 100 different classes, which will nicely simulate how you are going to work as a software developer or software engineer later on. So really spend a lot of efforts on the projects. Okay? And we also get a midterm test. The midterm test, even though it's a written test, but we will have that in the prison lab. Okay, so it might be just a composition of maybe multiple choice and some written questions. So Professor Jiang and I will talk about it a little bit more, okay, later. But at least you know there's a midterm test, also lab test, and also one final exam. Okay, that's how we are going to grade your course over here. Any question about it? Yes.
Talk about this regarding
Yeah.
GitHub. So are we going to use GitHub to post?
Oh, it's very good. Very good question. The question was, what about GitHub? Remember, one of the tutorials I gave to you is to apply the educational account for GitHub. Let me emphasize this. It is optional for you to get a GitHub. However, it's highly recommended because for you to practice using GitHub. GitHub has become really the standard way of managing your software, for anywhere outside the university. So I would say it's nice for you to apply for educational account. It only takes a few minutes. The tutorial video is not that long for you to apply. But now there's one thing I want to emphasize here. If you already got a GitHub account, most likely it only allows public repository, in which case you should never ever put your lab solution or project solution there. If you get caught, no excuse. It's considered as plagiarism or cheating. So what you should do is apply educational account, in which case it's free, and it will allow you to have unlimited number of private repository, in which case store all your lab work and project work there. Yes, question please.
Why not use GitLab?
You mean GitLab, just another platform for managing software?
Right, but it's free and it's private.
You know what? Are you talking about Bitbucket or GitLab? You know what? I'll look into that. Maybe not for this semester, but it's a very good suggestion. I'll look into that. Yeah. There's another platform actually called Bitbucket, also private by default. We just thought that GitHub is actually quite a standard way of doing things. Yeah. So usually people actually make all their code open to the public. But in our case, since we're in the school, so that's why we want to make it private. Yeah. Yes.
So possibly silly question, but why would code being in a public repository count as plagiarism?
The reason is we may reuse the labs for future semester. Maybe not necessarily in the immediately following semester, but we might reuse it somehow. Maybe just tweak it a little bit later for later semester. We don't want any dishonest students just to be able to Google the GitHub and get a source code directly. That's one justification. Yeah. But just try to conform to that. But if you got any issue with applying the educational account, just let us know. We'll try to help you get it through. Okay? Yeah. Okay, guys, any questions? Yes.
So there are two labs. There are two lab tests.
Okay, I'll go over it. Yeah, there are two tests. One is lab test, the other one is midterm test. Okay, how about this?
No, just for the lab test.
Lab test, only one.
Only one.
Only one, 10%. However, the 10%, that's why I said you really want to pick up the language rather quickly. For the lab test, there will be some stringent requirements. If you since you guys are third year, right? I hope it's not too unreasonable to say if you submit something that does not compile, you receive a 0, right? That's something I want to say up front, so you wouldn't be so surprised when we hand out the preparation guide. But let me just, before you say anything to that, okay? Let me just go over the dates for the test, so you will understand it's actually reasonable to ask you for that. Okay, so first of all, let's just go over, so these are the kind of, okay, let me just explain this table here. So you can see that over here, we are now in September 5th, which means today you were supposed to do lab 0, right? And then next week and the week after, you're supposed to complete lab 1. So which means lab 1 will be due shortly after September 19th, after the lab session, okay? So you should always go to lab session for help. Right, okay? And then we got, okay, and then you got to, okay, let me just go over this. October 24th will be the written midterm test. That was written exam. If we expect you to write some IFO code in the midterm test, but somehow you got the syntax wrong, that's okay, we can still tolerate. However, you can see the lab test is November 28th. We're talking about almost 3 months from now. Come on, guys, right? You can learn IFO, right? Whether you like it or not. Do you guys know that I actually used to take the same course back in 2005? The same course over here at York. I quite like IFO, I can tell you. But we try to convince you to like it too. Okay. Anyway, my point is for lab test, you really want, we're expecting you to know IFO pretty well. But you got 3 months to prepare. Okay, guys, any questions? Yes.
Is it attendance compulsory?
attendance, the question was, do you have to come for the lab session? No, you don't have to. But I would suggest if you really get stuck, you want to start early and then, okay, so typically, let's say if you're supposed to go to lab session on Wednesday, right? We will try to release the lab instruction the latest Tuesday night or later, late Tuesday afternoon. So you got some time to skim through the instructions there, and when you come on Wednesday, just ask the TAs or the instructor about how to solve problems. I think that'll save you time. But if you really got any personal reason that you really prefer working at home, that's okay. That's fine. Okay? But we do want to encourage you guys to come. Right? Okay, good. Okay, anything else? For the rest of the syllabus, there's simply just tentative topics that we listed over here. But today, I'm going to give you some motivation about these type of contracts. Okay. Any questions? Yes?
When will the project be released?
Project, good question. I think the project will be released. I can give some rough ideas, still tentative. Okay. You can see that from the table over here. You're supposed to do both Lab 4 and project over here in October 31st. You can imagine maybe shortly after the midterm, maybe October 25th or 26th. It's not confirmed yet. Okay. Any other questions? Yes?
Is the project going to be a group project or?
It will be, we're still thinking, but maybe most likely it will be a group project. We want you to get used to working with groups. And also, if you set up your GitHub account, you can also try to manage your project, right? With your, yeah, good. Yes, most likely group project, but we'll be more clear about the policy a little bit later. Okay. Any other questions? Okay, why don't we do some Java? Even though the course is about iPhone. Why not? Exactly, why not? We'll see, okay? By the way, it's university here, right? You don't have to agree with everything I say here today, but let's try to discuss.
Maybe in the future, change it to.
Maybe in the future. Well, we'll see. Yeah, we'll see. Okay, we'll see. Okay, let me just open the slides. And then let's talk from the beginning. I'll try to give you some logical reasoning why iPhone as opposed to Java was selected for this course. Okay. Okay. I may not be able to finish everything, but at least I will carry through the ideas. And maybe I'll let Professor Jane to finish the slides next week. Okay, by the way, for today's topics, you should really start reading. When I say OOSC2, that means Object-Oriented Software Construction, version 2. Okay, that's a required text, chapter 11. Okay, so motivation for this course. Okay, by the way, I'm going to put all the slides, all the notes, recording on the guest lecture section there. So you guys can just focus on understanding what I'm trying to say here. Everything's going to be available to you. Okay, so this course is going to be about design, right? The course title is called Software Design. It's not called Software Implementation, first of all. So now, what's really design? We try to talk about two aspects of the design. One aspect is about architecture. So back in 2030 and 1022, you learn about multiple classes working together by reference attributes. And also you talk about inheritance, polymorphism, dynamic binding, right? That's kind of one kind of architecture. But now we're talking more about design patterns. You have a particular way to organize all your classes so that they can work to solve a particular problem. Okay, so we're gonna, I'm just trying to be a little bit vague over here, but you will see that many kinds of problems there, each one of them will require a different kind of solution. So for you as a software engineer, when you see the particular kind of problem, you have to decide which pattern to use. There's no silver bullet. A single pattern is not gonna solve all the problem, no way. Okay, so architecture, basically you want to work with many interacting classes. So starting from lab number 3, we will have you try that. We'll give you some platform which we develop, and then we'll try to have you work with many classes. I'm talking about close to 100 classes together. Okay, that's going to be a nice exercise for you, right? Okay, the other aspect for design is called specification. And this part, we will have to rely on your knowledge in 1019, right? Which is one of the prerequisites for this course. So when you were back in 1019, you learned about logic, right? Implication, if and only if, stuff like that, and do some little bit of reasoning about your software. That's kind of the thing we want to show you in this course. So specification is really to say you want to be as precise and complete as possible when you want to express about the expectation. So here, what do I really mean by expectations? Let's say I'm the customer, and you are the software developer. When I tell you that develop a software product for me, from your point of view, you want my expectation to be as clear as possible. But for you, you have to really try to formulate exactly what my expectations are. So we'll see some example like this. And later on, we'll see that especially when your implementation involves like a collection, binary search tree, array, linked list, in that case, you have to be very complete and precise about the contracts. Because if I ask you to do something for me, and then you did something that's not so right, however, that is still within my expectation. So that means my original expectation is wrong. Okay, I'll be more precise about this when we see the example. Okay. Okay, for this course, as far as the implementation is concerned, we don't really ask for the most efficient data structure or algorithm, like what you were required by 2011, or some of you might have taken 3101 already, right? It's not that. For this course, we are more focusing on architecture and specification. And at the same time, we want to make sure whatever design you have, it has to be somehow implemented to make sure it actually works well. Okay? That's why I simply say a prototypical working implementation. Doesn't have to be that efficient. And however, you should really know that it's kind of beyond the scope of this course. Later on, you can say once you get your design, you can refine that somehow into maybe some more efficient data structure like a binary search tree, AVL tree, or hash table, right? So that's something you can do later, but that's beyond this course. We want to focus more on the activity you will do before the implementation design. Okay, so now, having said these already, so now, therefore, having a suitable language for teaching you guys about design is our main concern over here, right? So now we would like to see whether Java that you learned from the previous course that you learned, actually you should be very familiar with Java 1022, 2011, 2030, maybe other courses as well. So is Java really a good design language? Is it really good for the purpose of letting you learn about the design ideas we would like you to learn? Is it really good? Let's try, okay? Let's try to find out. Okay, let's first understand what a good design is. So in the next few slides, before I talk about how we can do design in Java, let's talk about what a good design is, just in general. And then we'll use those criteria to evaluate whether Java is good enough or not. Okay, let's see. We'll consider some very simple problem. Okay, terminology. Whenever you talk about design, you want to talk about three concepts over here: contracts, client, and supplier. Are you guys familiar with the client and supplier? Okay, maybe back in 2030. Let's review that quickly. Okay, it's really important, and also contracts. Okay, just this slide. Okay, supplier provides a service, or they are the implementer. Okay, so back in 2030, 2011, you're mostly the supplier. And who's the client? Maybe your instructor, because they grade your code, right? Okay, let's say now the supplier is a microwave manufacturer. Let's just use a microwave example. A client, apparently they uses a service provided by some supplier. Another example would be, let's say you go to your Java development, and then I'm trying to use the array list library class, the part of the API for Java. In that case, array list is a supplier, because the implementation is completely hidden from me. For me, I'm just using the methods that are provided by them, right? So I'm the supplier. I'm the client. Right. Good. So now I'll read through the critical part for you. The clients, they should follow certain instructions. That's very important. That's the obligation for the clients. Okay, for example, the supplier should assume the following things. The client, they should turn on the microwave. They should close the door. And they should hit something that's not explosive. Right? That's a reasonable assumptions, right? Let's say, for example, I call the manufacturer saying, oh, you know what, your microwave doesn't work because I didn't turn on the power. Do you think that they will ignore you? Most likely, yes, right? Right. So there are certain assumptions the manufacturer or the supplier can make for you as a client to follow before you can talk about if the service they provide is satisfactory. Okay, that's really important to know. Okay, so we talk about the obligation for the clients, and we also got obligation for the supplier. And if we follow the instruction, let's say me as a client, I turn on the microwave, I close the door, I also put in something that's not explosive. Now, if I hit on the button there, what should I expect? I want my, for example, my lunchbox to be heated properly. If it was not heated properly, that means there's something wrong with the microwave manufacturer, right? Then it's legitimate for me to complain, right? It's really about assumption and expectation, right? Over here, in general. Okay, and of course, if I'm using the microwave, I'm not supposed to care how exactly they implement that. You can see this analogy here is basically analogous to how you use a Java API, right? When you use ArrayList, you don't actually care if that's really how they implement that. You just use it, but take it for granted. Okay. So now let me just go through, and there's actually these terms about benefits and obligations. Okay, let's try. Okay, without showing you the answer. So now let's say for the clients, according to what I have said so far, what's kind of the benefits for the clients? What's the benefits? Service, given that if the instructions are followed. You can only talk about the benefits for the client if they have already satisfied their obligation, right? Exactly, very good. And obtain a service if they follow the instruction. Now, let's think about the other party. What about supplier? How would you expect the role to be arranged? The same? Or should we just swap? Money? Well, money, yeah, I agree. Well, yeah, money is outside the scope of the discussion. Yeah, I agree, yes.
Would it be to provide a service?
So you're saying provide a service would be the benefits or obligation for a supplier? Obligation, right? Think about if you are the implementer for a binary search tree, okay? What would be your obligation? Well, you got to make sure it works, right? Exactly. Okay, that means, well, and the benefits here, maybe this the trickiest one. So what's really benefits for a supplier? Well, when we talk about obligation for supplier, of course, you got to make sure the service works, right? But on the other hand, what will be the benefit for the supplier? That means the supplier doesn't have to implement the most tolerant microwave in the world. So you can simply assume that if you give me something explosive, I don't have to worry about my microwave being blow out, right? So that means assume the instruction being followed. Obligation, provide a service, right? You can see it's completely symmetric. Okay, guys, what was okay so far? Just to talk about general concept. So later on, when we so throughout the course of the semester, you should always think about when we talk about clients, when we talk about supplier, what should be the benefits and obligation for each other. It's really important when you do design. Okay.
But maybe they want it to be really efficient. The client wants it to be really efficient.
You know what? That's also that's more about performance. When you say efficient, that's it's interesting. Remember back in 2011, let's say I want to implement a priority queue. Okay, priority queue. If you simply say give me a priority queue implementation, let's say that's what you said to me, I can give you an array implementation, which means I always do a selection sort and then give you maybe the first element there. You cannot say I'm wrong, right? Because in that case, functional-wise, I'm satisfying what you expect from me. But about performance efficiency, that's more the non-functional requirements, which we don't discuss in this course. But it's a good concern, yes. Okay, guys, please feel free to interrupt me. I'm only going to see you guys for once, right? So, well, maybe another time if Professor Jian cannot make it later. Okay, so there is a contract between the two parties. Okay, let's try this. How can a contract be violated? Let's say if the instructions are not followed, whose fault is that? Clients, exactly. On the other hand, if the instructions are followed but the service is not satisfactory, supplier. Okay, so far so good, very good. Okay, let me make it a little bit more coding for you. Okay, let's just go over some Java code. Okay, so just make it more visual to you. Let's say we have a microwave class. We got two implementation attributes on and locked. On can be true or false. True means the microwave is on, and lock, if the lock attribute is false, that means it's unlocked, right? Something like that. And then, so you can think about microwave is really the supplier. So we're going to have another class being the client. And let's say we just get power and also locked. We got two mutated methods here, right? We can turn the microwave on or off, and we can also unlock it or unlock it. And let's say we also get a method here called heat, okay? So now, for the heat method over here, so we are heating some objects over here, right? So now, for us as a supplier, we are assuming that anyone who's trying to use the microwave is going to make sure it's on, locked, and also nothing explosive, right? Okay, let's see how we can express that. Let's say we get a microwave user here. We just get a main method there, right? So that's a client. And then we have microwave objects over here. And then we say some object. The reason I put a question mark is it can be anything, okay? And then let's say the client tries to, you can see when we say m.power, I want to show you one thing here on the iPad, so it's important to see. Okay, let's see some annotation over here. Let me just get my Apple Pencil here. All right. So now, first of all, you can see that when we are trying to make this method call over here, okay? So now we want to know who is the supplier and who is the client, right? Since you're trying to call on this context objects, which means the heat surface is provided by this object over here, which was instantiated by this class over here. So this is the supplier. And how do we tell who the client is? Well, since you're calling this method here in the context of this microwave user class, so that is the client. Okay, that's how you tell, right? So this is the client. That's the context of call. Okay, guys, make sure you can get this point here. Okay, again, let me recap very quickly. Since we're trying to make this method call here m.heat, so m, the context object, is the object that will provide the heating surface. So that's why it's a supplier. Symmetrically, since we are trying to make this heat, request this heat surface in the context of microwave user class, that's why it's a client. Okay, so now what we want to make sure is before we try to make this method call over here, the obligations are satisfied by the clients. Remember, you can see it's trying to the power over here. It's trying to turn it on, right? And also microwave user is trying to lock it. However, you can see that potentially it can still violate the contract, right? Can you see why? The question mark over there, you can see that's why I put question mark here. That means the object over here, which is in complete control by the clients, the client didn't really check it carefully, right? So that means we don't know yet if this might be a safe call. Okay, I just want to illustrate this to you. On the other hand, let's say somehow I instantiate this to be, let's say, lunchbox, okay, a normal lunchbox, for example. Oops, sorry. Lunchbox, and then let's say that means we can pass the lunchbox over here and make the method call. At the end of, let's say once this method call completes and terminates, okay, let me just mention one more terminology to you. So we say this, the arrow over here is called a before states. So it's the state of the object before we try to call the surface, right? And this second arrow over here is called after states. So that means that is the state after we have done the surface, right? So now the before states must be such that the lock is on, the power is on, and also the object cannot be explosive. And what about the after states? You want to take a guess? What should be the after state? Should be such that yeah, exactly, the food or the lunchbox is warm, right? Okay, so you can see that. Good. Very good. Okay, again, client, supplier, and contracts, and before and after states. We'll get to have you write some Java code in just a moment. Okay, so it's a client-supplier relation. Okay, actually, might be the first course that we really try to be very explicit and formal about client-supplier. You have been doing client-supplier even since you were 1022, or even 1012. Whenever you're using a software package, you are the clients, basically. We just never formulated that like this way, but it's worth knowing. Okay, the client and the supplier, as I said, okay, nothing new. Okay, so now the contract is honored, which means it's not violated if right before the method call, the before states, remember? So right before the method call, this is right before the method call. And it must be that true and true, right? It's be on and locked. And also the object is not explosive. Right after the method call, which is the so-called after states over here, it must be such that object is properly heated, right? Exactly like what you guys said. Okay, and now if there's anything that fails, it's a contract violation, okay? Starting from Monday, we're gonna go back to IFO, but before that, I want you to pay attention to contract violation. Somehow contract violation is not so the same as exception in Java. As we'll see, the way we do exception for implementing precondition in 2030 is not the best way to do it, okay? It's only a okay approximation, okay? So when we see contract violation there, try not to say that's exception, right? It's a different thing, okay? Contract violation simply means if there's anything wrong, either from the client side or the supplier side, okay? That's what it means, okay? Okay, now let's try. If m.on is false or m.locked is false, so that should be a contract violation. But now, which side should be blamed? Your clients, right? Because the client is supposed to make sure it's on, it's locked, right? Good. Microwave fault, well, microwave user. Okay, similarly, if the object is inexplosive, of course, microwave user, right? So now, if a fault from the client a fault from the client is identified, it's something called precondition violation, as we'll see later. But in that case, method call will simply not start, right? So that means we want to make sure whenever we call, maybe it's better to show the annotation here. That'll be better. We want to make sure over here, if the runtime system allows this method call to be executed, it better be that the before states satisfies all the obligation of the clients or satisfy all the benefits of the supplier. The same thing, okay? It's really important. Okay, and then if the method executed, but the object is not properly heated, of course, that'll be the microwave's fault, right? Okay, that's about the microwave example. Is it okay? Just to give you some intuition. Okay, we'll do something different. Okay, now this one just showing the code, but more about explaining client supplier. Okay, let's go over one more slide about what a good design is, and then we'll use that criteria to evaluate how suitable Java might be. Okay, let's see. There are certain issues I would like to bring your attention to. Okay, okay, a good design should be explicitly and unambiguously describe the contract between the clients and supplier. When I say explicitly, that means it should be shown as part of the API of the service or the methods. It should be. Otherwise, for any client who's trying to use your method, if they are not really aware of the preconditions, then that's not good. They should know exactly what they should follow as the instructions. Okay? And also unambiguously means there should be no gray area. It must be very complete. To say if I am the supplier to implement some service, if somehow I got some faulty implementation, it must be able to be caught by the contracts. Okay? But we'll see. For example. Okay, we call such a relation specification. Okay? And then when you conduct software design, you should really be guided by appropriate contract between users and developer. Always think about what the benefits and obligations are. Okay, that's what I mean. Okay, okay, now one more thing to say. Well, you might think that, wow, if the precondition is so useful to filter out invalid inputs, why don't I simply go extreme? Why don't I simply just get my precondition to be just false? Have you think about it? Have you thought about that? Logically speaking, what is the strongest predicate you can ever get? What the strongest proposition you can ever get, logically speaking? False. What does a false precondition mean? That means whenever you're trying to give me any input, I'll simply reject. So that means I will never actually let you satisfy that, right? That's not good, right? Also, you don't want your precondition to be so weak. Logically speaking, what's the weakest proposition?
So
True.
Always accept.
Yeah, that means true. Now that means I don't care what you give to me, I always accept it. If you have a very, very weak precondition from the supplier side, this is what's going to happen. So that means, okay, let's say you're asking them to, first, for the client, you shouldn't ask them to assemble internal parts of a microwave. But, okay, so the working condition for supplier should not be unconditional, which means should not be true. If the precondition is simply true, what does that mean? That means you can actually expect a microwave, power off, door open, it can still heat something that's explosive. That's what it means. But you don't want that to happen, right? Anyway. Okay, just read through this description when you get the slides. I'm just trying to make a point here. Okay, so now you as a designer should always think about the balance between obligation and client and benefits. It's really a balance you want to learn by doing the lab assignments and also the projects, right? Especially the projects. Okay, let's try some exercise here. What is the obligation of a binary search user? I'm talking about the clients. What's the obligation for doing a binary search? Let's say we're trying to do a binary search on an array. Increasing order, which means it's sorted. It's very good. Okay, good. Wow, you guys are doing very well. I remember I taught the same course with the same question back in fall 2017. Nobody got it right. You guys are good. Good. Okay, that's right. You got to be sorted. Okay, so just one example there. So you should always know about the precondition. Okay, so now, here's the thing. When contract is violated, there should be only one side to be blamed. Okay, it should be just one side. You shouldn't say when the error occurred, it's actually both the supplier and the client's fault. In that case, you don't know who to actually be responsible for the error, right? We'll see that sometimes you might end up with some bad design where both the client and supplier have not done their job properly, which can occur in Java. I will show you. Okay, the design process I'm talking about using obligation and benefits to guide your design is called design by contracts. Okay, let me just preview a little bit. In the following slides, I'm going to show you gradually the ideas about the ingredients for design by contracts, which are preconditions, postconditions, and class invariants. So these are the three things. Okay. Okay. Yeah. Let's try. Let's go over the requirements for a simple problem there, and then we'll see. I'll give you 5 different versions of the Java. We'll go very slowly, okay? I'll go very slowly, at least in the beginning, and then I'll go a little bit faster to get you the idea to a different version. But there will be 5 versions of Java to solve the same problem here. Each one of them got some design faults, I would call, okay? That will be the very straightforward solution you will develop based on what you learned before, okay, for Java. But we'll program together. Okay, let's talk about requirements first. Let's say requirement number 1, each bank account is associated with the name and balance. Okay, string and integer, easy. Requirement number 2, we may withdraw an integer amount from an account. Okay, by the way, requirements, if you're really interested in doing requirements engineering, you should take 4312 later. But here we're just saying requirements are sometimes can just be vague, incomplete, or imprecise. Okay? I can tell you that there might be some missing information in the requirement, which is intentional. Okay? Number 3, each bank stores a list of accounts. So here I'm just saying a list. It doesn't have to be linked list, doesn't have to be array, just anything, just a list of accounts. Given a bank, we may add a new account in it. And also, given a bank, we may query about the associated account of an owner. You know, something like that, very easy. Okay, and one more. Given a bank, we may withdraw from a specific account, and we identify by the name, okay, of the owner. Okay, so now for the purpose of illustration, I'm only going to say, let's try to work on implementing requirements 1 and requirements 2. It sounds simple, doesn't it? But you will see things might get a little bit messy if you try to do that in Java, to do things properly. I'm talking about good design, okay? We'll see. And this may not be as easy as you might think. How about, guys, let me give you 30 seconds. Think about how you, okay. I will just make you more focused. 1 and 2. I'll give you just maybe 30 seconds. Yeah, 30 seconds will be good. Think about to implement requirement 1 and 2. How would you do it? Especially given that we learned about contracts, precondition and postcondition, or what should be the obligation benefits, etc. Think about it for 30 seconds, and then we'll see exactly how we can go from there. I'll give you 5 versions of Java code. Okay, and then we'll criticize them together. How many classes do you need, for example? And how would you design a test for your account class, right? Things like that. Exception, I like that keyword, yes. It seems to us, in order to implement something as an obligation, exception seems to be the way to go, right? I can give you another hint. I'm not sure if any one of you actually use something called assertion in Java. Let me tell you quickly the difference. So back in 2030, you use about exception to implement precondition. The reason is the precondition will appear as part of the API of your Java methods, right? Let's say this. If I have a Java withdraw, and then I say withdraw my, we'll say throws, like the account not sufficient balance exception, something like that, right? If I do this one, that means anyone who is trying to use this method here, they should have a try and catch, right? That's Java, okay? Let's make sure we understand that. On the other hand, if you use something called assertion in Java, assertion, you can simply say, at a certain point of my method there, I say assert if something is true or not. If, for example, if the balance is positive. If it is, pass. If it is not, throws an assertion error. However, the assertion is not part of the API of the method if you have it in your method. Okay, that's the only difference. So exception appear on the API, assertions do not. Okay, that's just Java specific knowledge. And by the way, for the 5 versions of code, I'm going to make it available to you as well, so you can play with them. Okay, and try to see if you're interested in doing requirements 3, 4, 5, 6, and see how you can implement them as a good design with very clear pre and post conditions. Okay. Okay, let me just try to do it. Let's just do maybe at least the first and second version very thoroughly, and then we'll see how the time goes, and then we'll maybe I'll let Jack finish the rest next time. Okay. Okay. You can download the source code. This link doesn't work yet. I just fixed the link, but I'm gonna upload. Make sure you get a correct link. But later on, you will be available. You can just download the Java code. However, in order to that's how you import a project. There's a tutorial video for that, very short. And one thing to note, if you want to use the assertion in Eclipse, you have to set some particular configuration in Eclipse. But this one shows you how to do it if you're interested in trying the Java code. Okay? This part is optional, just out of your curiosity. Okay? If you're not happy with Java from this lecture, you just want to do IVO, forget about this slide. Okay? Which I'll be happy to know I'm very convincing here. Okay, version 1. Let's do it all together. Okay, so version 1, let's say we just want to have one single class, account class. Okay, and now account class version 1, we have owner, we have balance, right? So sorry, since I said so many things, let's require 1 and 2. 1 is it should be a name and balance, right? Number 2 is about withdrawal. Okay, don't forget. Okay, one thing to know, that should be always positive. Okay, just something to pay attention to. Okay. Now let's go back, go here. So we got owner and balance. Apparently that one is trying to somehow implement requirements Y, right? But not so completely. Can you see? Because here, somehow the balance is always positive, it's not reflected. Is it? It's not yet. Okay, and then we have get owner, get balance, just standard excessive method. And we also have account V1 to create a new account. And then we also got withdraw, okay? It's very straightforward, conceivable implementation there. Okay, also to screen. Okay, now, question for you. Do you think this is a properly designed Java implementation? Let's have some discussion here. Just tell me what you think is wrong, and give me some example. What can go wrong?
Balance could be less than 0.
Less than 0? When can you actually get an error? When you call which method? The balance, maybe the constructor, right? Withdraw. Okay, yeah, actually that's right. Okay, you're talking about calling this method here, yeah. Right? Let me try to complement what you're trying to say here. Maybe even earlier, when you are trying to call this constructor here, what if I give you -5, right? And currently you just do it, right? Which is not good, right? And if I give withdraw -5, you know what? If that can be done, that'll be great, wouldn't it?
Yeah. No, but sometimes like in certain condition, you can actually get
You can,
get 5, but the balance is gonna get -5.
oh no, I'm saying the opposite. Of course, if you say, let's say I say a million. If I say withdraw a million from my account, it should really subtract a million, right? But if I say minus a million, right, then it's different, right? You don't want it to happen. What?
What about if you just make a method called precondition check? There we go.
Method called or what do you mean, in where?
In that account class.
Account class, precondition.
Before you do anything, you always call that method and check if precondition.
You know what? I wouldn't say that's wrong. So that means, thinking this way. If you have 10 methods in your class, does that mean for each method you're going to have a separate method to check its precondition?
No, you just call that same method.
Well, what the problem is, the precondition for each method might be different.
What about inside the withdrawal?
Case
Huh?
inside the method.
Inside the method. Oh, I tell you what, I like that solution there. Even though my solution is not exactly identical to yours, it's basically doing the same thing. You're trying to say, we're going to write some code inside your method to check the precondition. Am I right? Great. Either you use a helper method, or you simply say, if this happens, throw some exception. It's the same thing. Okay, I agree. Okay?
What if it's inside the withdrawal? So you just say if
Oh, yeah.
if amount
Yeah.
amount is
Yeah,
then
exactly. So maybe that's exactly what you will see in version 2. To say, I can say, if the amount, for example, is negative, I'm going to throw illegal negative amount exception, something like that, right?
Yeah.
Okay, good. So guys, you pretty much can appreciate how wrong version 1 is. Let's say maybe that's what you will write in 1022, right? Okay, that's a 1022 level, okay? That's not good, okay? You pretty much got everything here. Let me just see if there's anything I would like to mention. Yeah, that's a problem, always positive. That's the thing we didn't satisfy, okay? Very good. Okay, it's now reflected in the above Java code. How can we improve? Okay, once more, you can try that. If we try to pass -10, of course, it's going to just accept it and say Alan's balance is -10. Okay, pretty good. Okay, so you can read the rest. It's pretty straightforward. Yeah, you guys got the idea. Okay, so now I want to mention one more point. So here you can see that when we can have a console interaction like this, the client passed -10. The supplier accepted that and display -10 as the balance. Whose fault is that?
flood.
Really?
Flood.
Yes, want to say something?
Goes into the contract. That comes from the
Contract is false, right? Because in some way, in this case over here, the supplier is the client is ignorant. They didn't really just give you a positive value. The supplier is also too accommodating. They take anything, right? So both sides are to be blamed, which means the contract is not right over here, right? Okay, good. Okay, you can read, lack of defined contracts. Okay, good. Okay, just another example. If you try to withdraw minus a million, right? Okay, of course, that shouldn't be allowed. And when I say it shouldn't be allowed, that means, let's imagine that you're trying to execute a code line by line. So when you try to execute this line over here, even before you get to the body of withdrawal, it should stop. It shouldn't even go through, do the withdrawal transaction, right? It should just stop there. Okay, good. Okay, you can read the rest. It's pretty much what we said before. Okay, and just another example here. Let's say you got, that's something you guys didn't say. If you got balance 100, I try to withdraw some positive amount, but it's too big, right? Similar, right? Similar idea. Okay, so we got several issues here. Okay, so but remember in requirements number 2, it was incomplete. Because requirement number 2, let me remind you, you can check the slide later. It only says you should support withdrawal, but it doesn't really say what withdrawal should be constrained, right? So if you try to withdraw too much, there should be some issue there. Very good. Okay. So now, how should we improve it? Right? Basically, we're gonna implement some so-called preconditions, which means we want to make sure there will be some certain circumstances under which we shouldn't execute the method body. We shouldn't do the withdrawal, or we shouldn't even create the account objects. That's what we'll do. And now, let's do some little bit of practice here. What should be the precondition for divide over here? Y shouldn't be 0, right? Good, okay, good, that's easy. What about this? Let's say binary search, and then it should return a Boolean, of course. Sorted? Which one's sorted? XS, right? Yeah, very good, okay? Okay, very good. So now, here is what I claim. It's not so ideal to do preconditions in Java. Let's think a little bit more about here. When we talk about preconditions over here, okay, let's have a look at this. Let me just look at that, okay? So now, when we say preconditions, that means only under such circumstances can I provide a service of divide to you, right? That's what preconditions mean. However, how would you implement this in Java? Would you say, if y is not equal to 0, I'm going to throw some exception? You would say the opposite, right? You actually say the non-logical negation of that. You would say, if y is equal to 0, I'm going to throw this error conditions. You can see the difference here. I really want to say this. Okay, let me just make it a little bit more clear to you. Okay, over here, we have divide, and we got x and y. When we say precondition, right, it's really about a service condition, which is y is not equal to 0, right? Only under this circumstance can I actually provide to you some reasonable service for divide. However, the way you do this in Java, you wouldn't simply say, you cannot just reuse this condition here over here. You cannot. You got to somehow do some logical negation, right? The logical negation of not equal to would be equal to. So now in Java, exceptions, we shouldn't really call that precondition. The more precise, the more accurate way to call that would be is error conditions. It's not service condition. Which means only under this condition, only under the negation of this condition can we actually provide a service, right? Okay, I'm just trying to be very precise over here. Okay, that's an error condition. Okay, so now that means at least we can do something. You can always take the logical negation of something. So I'm just saying that's not perfect, but just some reasonable approximation. Okay, so that means you have to throw the exception if y is equal to 0. You can see y is equal to 0 is exactly the negation of that, right, over here, right? And similarly for the other one. Okay, so now, so it should be preferred to do some valid inputs as opposed to erroneous input, right? That's my point. Yes?
Exception would be a good design or assertion. So like if we use assertion by here, so will it be considered as a good design or a bad design?
I would say it's a bad design. The question was, how about we just simply use assertions for preconditions? Remember what I said before, in Java, if you simply put assertions in the beginning of your methods, it's not in the API, so that's not good. You want the precondition and postcondition to be part of the API of the method, which means anyone who's trying to use it, they will be well aware of the contracts. You don't want to sign a contract where you don't know what the terms are, right? Which is dangerous, right? Okay, good questions. Okay, let's go on over here. So now let's create version 2, okay? Let's try to improve the matter, okay? So now version 2, let's say we got account version 2, v2 here. So now you can see that over there in the case of the constructor here, we say if the balance is negative, then we'll throw new balance negative exception, right? It's a reasonable approximation, okay? But we're gonna see there's one issue we already mentioned, because somehow balance less than 0 is more like an error condition. It's not service condition, right? That's number one. And number two, let's say this. If I say this might throw this exception here, that means for any other clients who is going to call this constructor over here, account v2, they are forced to do try and catch. Am I right? And that means the more preconditions you might have for the service, the more code client has to write for try and catch, right? So let's get it clear, okay? That certainly is a disadvantage, because if you're trying to make your contract clear from the supplier side, why would you have to bother the clients to actually be complicated for their code, right? That's the kind of the argument here. Okay, and then we also got withdraw over here, so you can see we got actually two error conditions here, if amount is negative or if the amount is somehow too large. Okay, you know, guys. Okay, let's since we certainly wouldn't have enough time to go through everything, but let me have a test for you, which will be mentioned later in the slides. Can you see anything wrong in line number 13? Nothing about exception here, logically. Logically speaking, you actually encounter many cases like this for this course. Yes. Ah, very good. Okay, let's try this here. Okay, so now imagine that. Okay, let's make one example. Make it very clear. Let's say the current balance is simply 100. I only got $100. If the amount is 99, 100 less than 99 is going to be false, which means I wouldn't throw this exception. That's an okay run. Okay, but now let's say I'm trying to withdraw exactly $100. In this case, 100 less than 100 would be still false, right? Would that be a problem here? What problem is that? It's not going to go through, right? So that means it's not going to throw out this exception here, but it will still do this balance subtraction. Guys, you see the logic here? Let me just do it once more, okay? It's a bit tricky, I know. Okay, again, we got balance $100, and we are trying to subtract 100 from that. Okay, so now the error condition tells us the amount must be strictly larger than balance. 100 is not strictly larger than 100. So that means we will not report an error in this case. We'll simply just do the surface over here. So that means 100 minus 100, we got 0. Does that violate anything? Are you sure? let me remind you very quickly. It does violate something. Okay. Yes, let me just show you, okay? Yeah. Let me show you very quickly. Remember number 1 over here? Always positive, right? So that violates something, right? So the precondition there has a missing case, okay? Okay, let me just go back there, and then let's just go from there. Version 2, let me just go over there. Okay, so we are saying that basically there's some problem with this equality here. That's something that's deeper. So that's why it does require some logic over here. Be careful. Okay, so we say that somehow this precondition is not good enough because it misses the case where amount is exactly equal to balance, for which case you should also throw the exception, but in this case it doesn't. That's a problem. Okay. You can think a little bit more through about this, okay? So there are certain issues over here, but you know, it has some good thing over here. And one more thing to say. We are saying that every account must have some positive balance, right? Whenever you're trying to make some requirements on every instance of a particular class, that means you want to have some global invariance. We call invariance over here. So when is some property to be called invariant? If you want a property to be satisfied by every instance of the class. So now we are saying that for every instance of the account, the balance must be positive. So that's why it should be just an invariance, which means it never changes. It's always there. Okay, let's just go through a little bit. I should have another 7 minutes, 8 minutes. Okay, let's see how much we can do. Okay, over here you can see we try. Now if we try minus 10, it will report some error. Okay, it will say throw the exception, and then the catch part will actually give you some proper error message, right? So that means as soon as we hit line number 5, we do not get a chance to go to line number 6, right? We just go to the catch block. Okay, that's a good thing about version 2. Okay, you can read through the rest, pretty much what I said. Okay, let's see this. And if you try to do minus a million at line number 8, you will also be caught properly, right? So I don't have to repeat. You can just go through the code over here. So you can see this is good because it will go to this exception here, right? It's highlighted. And also, if you have, let me see if there's anything to say. One thing to mention. Let's say this. Now, have a look at the, you can see that the try and catch block for the client code is a bank app, right? It's a client code. The client code is getting a little bit too complicated, don't you think? You can see that the reason that we should have the catch block for line number 11 was because in line number 5, there might be some balance negative exception thrown for the constructor. In line number 14, we need a catch block simply because in line number 8, we have to make sure the amount is not negative, right? In line number 17, we also need this catch block because there might be some exception thrown from line number 8 when the withdrawal amount is too large, right? You can see there are 3 kinds of errors that might occur at the runtime. So that's why we need the 3 catch blocks. Yes.
But why the client is gonna be unhappy with this?
Well, think about this. I'm trying to use your code. Maybe somehow you're too much into Java from before. You're so used to this kind of. Okay, how about this? Let me put it another way. Wouldn't it be so much nicer to say, if I try to use the service like that, I'll just do this block of code. I don't have to worry about these kind of exceptions here. Which means if there's anything that's being violated, it will be reported at the runtime anyway. So you don't have to really write the catch block like this. You don't have to. You can get away from that when you don't have to.
If the catch is the problem, I can do it other ways, right? Like I could use something like code that I create, right, without doing catch.
Yeah, you will find that, yeah, it's a good point. So you will find that in many of the cases, actually, if you actually run into certain, let's say this, when you're trying to do this one over here, let's say withdrawal amount is already negative, you simply just cannot complete the transaction, right? In many of the cases, you simply just want to stop. In which case, this one doesn't do too much, right? You rather just have the runtime system to report the error to you right away, right? You don't have to do this by yourself to say catch. What I'm trying to say is the Java way of handling exceptions is going to force the clients to do the try and catch block according to how many preconditions you might have from the supplier side. We are so much used to it, so we might think that's okay. But if you later on, when you see how things are done in IFO, for example, it does things in a different way, which means when I'm trying to use any service there, I can definitely look at the contract view of the method. But at the same time, if I'm trying to use the method, I don't have to worry about checking the contracts myself. It will be managed by the runtime automatically.
Well, I can make it harder for me, but not for the client. Like I can make more codes so that the client doesn't need to do the catch thing.
How? Tell me how in Java. You know, the thing is, as soon as you make the exceptions checked in Java, try and catch block must be there.
What about if I don't do exception? I just do if conditions.
Well, if you do if conditions there, what's going to happen?
Case statements.
But the problem is, let's say this. Let's say we get rid of the exceptions there. If you simply say if, okay, let's think about this. Let's now go back to withdraw over there. How about just this one here? Okay, let's say for the constructor here, we say that if the balance is negative, we throw exception. You're suggesting that we shouldn't really use exception anymore. So what would you do if you say, line number 6, I don't like about exception? What would you do? Print out something to the console?
I just print something.
That's not good. I tell you what, printing out something to the console is not good. It's actually even worse because for exception, if exception occurred, the client cannot continue with their code, right? Because they already violate the precondition at this point. But you print something there, that means they can still continue.
I can do break. I can do break.
No, you don't see what I meant here. Okay, guys, let me just illustrate to you very quickly. Okay, let's say this. Okay, we don't have much time, right? Okay, let me just illustrate this. What I would tell Professor Jane is he should finish the slides. How about let me just answer this question very quickly. So why is print statement not a good idea? Let me illustrate that. Give me just 2 minutes, okay? And then, okay, so now let's say in the account constructor over there, remember one of the argument is the integer balance. Okay, if I do if, let's say balance is negative, I will do system.out print line, right? Printing out an error. Print line, and then error. Something like that, okay? And that's the client side. Sorry, that's the supplier side, okay? Now for the client side, I will have some account tester, okay? Let me try this. If I say account ACC is new account. Okay, and then some name over here. I'll say minus 100. Okay, the next line for my code, I'm going to say system out of print line success, for example. Okay, what's going to happen here? Let's try at the runtime. 100 over here is going to make it true. That means over here it's going to print out error. What's going to be output to the console? Error, success. You see my point here? So somehow, you see, let me just, it's a very good question there. So here tells you exception is a better solution than printing out an error. Because if this was an exception there, that means as soon as the exception occurs, it's going to stop the execution right there. But for print statement, no. So you can see you got that kind of funny situation over there, right? Okay, guys, let me wrap it up in 1 minute, okay? Basically, I'm trying to make the point, at least in my part, to say there are many cases, even for the simple cases, it's better to use a good language rather than Java. We want to get away from exceptions. We want to get away from assertions. We want to have a clean language to show you exactly what the preconditions are, what the postconditions are. Okay? So I'm going to ask Professor Jian to actually go through the rest of the slides, and then you're going to need, and then we assume, how about that? We assume you are kind of convinced that we're going to use iPhone. But, talk to us throughout the semester. Okay? Good luck.